Today we're going to talk about doing EnergyTrace measurements with the auxiliary port of a standalone XDS110 Debug Probe. The XDS110 Debug Probe has two output ports. One is the traditional debug, which you do JTAG, CJTAG, SWD, and the other one, which you actually use, has some auxiliary functions. The function that we're going to discuss today is EnergyTrace, meaning the ability to measure current going to the device, to the target board or system, and measuring the consumption, the current consumption of it, and doing some calculations for power and energy on top of that. So first of all, you have to connect your cables to the XDS110. You have two ports to put them, and the first one that is shown here in the picture is the connecting the auxiliary port cable. It's a 14-pin high-density cable. So you connect it to the auxiliary port, and then you make the connection to the small breakout board to it to actually break. So it breaks out all the signals on this cable. Just one hint: don't connect the cable. Pay attention to how you connect the cable. So if it looks strange, the order of the pin ones on the board, just like shown in the picture, you probably connected it wrong. You can actually reverse the cable, and you'll be a little bit smoother how to connect to it. And then you do the connections to your board. You basically make sure you're connecting the target V out, which is TGT supply V out rather, to the 3.3 volts line of your board. Well, it can range from 1.8 to 3.6, so VCC. And the other one is the GND that you can connect to ground point in your board as well. Now just showing connected to my TM4C1294 Launchpad. Then you go to CodeComposer Studio to configure all the system. So basically, you actually grab create a new target configuration, and then you will select, of course, the XDS110 Debug Probe and the TM4C device that you actually are going to use. In this case, that's my board here. So one interesting thing is that if you actually try to do the test connection right away with using the defaults, you actually run into a target supply problem. Why? Because the debug probe is not configured to provide power to the target. He always by default assumes that is actually the target has power. This is the most conservative way to actually avoid any collapse between the power trying to be supplied by the probe and if there is any power on the target. So what you do is probe supplied power, and you actually type in a number between 1.8 and 3.6 volts, so the probe can actually supply power to the target. Now, obviously, if you go to a test connection, I see my LED blinking in here, and of course it does a test connection, and it turns off. Basically, that's an important thing too. The board will turn off, and it will be only turned on when the debug probe is actually active, meaning it's connected to CodeComposer Studio, and in this case in the test connection button as well. So if you see your board turning on and doing something and then turning off again, that's normal. Or if you, before you actually apply the test connection button, your board will be always powered off because the debug probe is not active yet. So well, we can do simply we can either simply launch the EnergyTrace, the offline EnergyTrace. So my board looks powered off. Now it looks powered on again because EnergyTrace is actually, it tried to probe the probe. So it's interesting. By default, by default, CCS uses configures USB FATs. This configuration can be found in Window Preferences, and you go here to EnergyTrace technology. This is the major configuration, the main configuration for a EnergyTrace session that is not tied to a debug session, meaning I didn't launch the debugger on CCS. So this by default is actually set to MSP430 and connect it to a USB 1 port, you can simply select here to the XDS110, or no problem, you can simply go and try to launch it, but you actually, as it did, it will auto-detect for you. So we'll do the auto-detection for you, that meaning, okay, I could find, CCS could find automatically the XDS110, and I'm actually going to launch it. So here's the EnergyTrace. There's no debug session, note this, very important, but here's the EnergyTrace, and the board is actually turned on. So you can simply go and hit play, so you start the data collection on the board. And the board is actually operating, so the board is fully powered, and of course you can have all the measurements and about 137 or whereabouts milliwatts of power, obviously energy, this is the functionality that you already know, and the voltage 3.3 volts. So that's how you actually connect and actually do a simple EnergyTrace measurement. Of course, my code doesn't have anything fancy, doesn't even blink or do anything fancy. So that's how you see the power curve very stable. And here, pretty much, it's running freely. But at any rate, that's how you actually do the connections and probe EnergyTrace. You can explore additional functions of EnergyTrace. You have additional videos here on the channel, and you can explore more about this in other links that I'm gonna put down below. Thank